So SI quantities, graphs, and motion of an object. Question 1. Which of the following quantities has SI base unit kilogram, meter square, second raised to power minus 3? So how to solve such question if we want to represent the base unit? You can also use the chat to state the answer, but I'll discuss each of them. Not all MCQs, about 10 MCQs are there, so I will discuss about 5 and then we'll move to structure questions. But you can also use the chat to state the answer if you think you know the right answer. So for this question, which quantities has the SI base unit as kilogram, meter squared, second raised to power minus 3? How to solve such question? To solve such question, you have to first write a formula. Any formula you remember for the quantity, you can use that formula to work out the base units. Like example, if I want to work out the base unit of force. So what will be the base unit of the force? So first we write F is equals to ma. Force is equals to mass into acceleration. And as I mentioned, you can use any formula, what you remember, you can use that to work out the base unit. Then we write the unit for each quantity. The mass of an object, the SI unit of the mass is kilogram, kg. And SI unit of acceleration is meter per second square. So it will become kilogram meter per second square. When we simplify, we move all them in numerator. So force is equals to kilogram meter second raised to power minus 2. So force is equals to kilogram meter second raised to power minus 2. It means this cannot be force because we want kilogram meter square second raised to power minus 3. The second one is a momentum. So for momentum is a product of mass and velocity. That's a formula for momentum. The mass of an object is kilogram kg. What about speed of an object? Speed of an object is meter per second. So the unit of the momentum is kilogram meter per second. So second is divided, it will move in numerator. So it will become kilogram meter second raised to power minus 1. So it will be kilogram meter second raised to power minus 1. So it does not match with kilogram meter square and second raised to power minus 3. So it cannot be B. Then we check power. Power is work done per unit time. Power is force into velocity as well. Like different formulas are there for power. And force, we already worked out the base unit. What is the base unit of force? Force itself is kilogram meter per second square. And what about the speed or the velocity? That is meter per second. So when we simplify this, it will turn out to be kilogram meter square second raised to power 3. This is in denominator. This will move in numerator. So it will turn out to be kilogram meter square second raised to power minus 3. So the base unit of power is kilogram meter second raised to power minus 3. Kilogram meter square second raised to power minus 3. So means it match with option C. So C will be the right answer. And what about the work done? We can also work out the base unit of a work done. So even though we know the right answer is C, but we can also work out the base unit for work. So the formula for work is the product of force and displacement. The force, the base unit of the force, that is kilogram. Unit of the force is Newton, but the base unit is kilogram meter per second square. So it will be kilogram meter per second square. And then distance is in meter. When we simplify, this will turn out to be kilogram meter square by second square. Second square is divided, other side will be multiplied. So it will turn out to be kilogram meter square second raised to power minus 2. So this will be kilogram meter square second raised to power minus 2. So C is the right or valid option as it matches with kilogram meter square second raised to power minus 3. So important thing to solve such question, whenever you want to represent the base unit, you should always write the formula, then represent each quantity in terms of base unit, and then simplify the units. Then in question 2, which of the following statement describe the gravitational field strength acting on a body at point? So what is the gravitational field strength? What is the value for gravity? The gravitational field strength is basically like we have the formula weight is equals to W is equals to mg. Weight is mass multiplied by gravity. So weight divided by mass is equals to gravity. So weight is there in Newton. Like the question is, which of the following describe the gravitational field strength? So which one describe the gravitational field strength? So value of G. So weight is there in Newton and mass is there kilogram. So basically it's the gravitational force, because weight is the force, the gravitational force per kilogram or unit mass or on a unit mass. So value of the gravity, as we say, the value of the gravity of Earth is say 9.81 Newton per kilogram. So means this much force experienced by each kilogram or unit mass. So that's why the value of the gravity or expression due to gravity, that is gravitational force per unit mass. So B should be the right answer. The diagram below shows the velocity of an object before and after a force is applied. The magnitude of the velocity did not change. Which of the following represent the change in the velocity? So we have to do a vector addition. How to work out the change in velocity? Change in velocity is final minus initial. Like this one is initial velocity, say u, this one is final velocity v. If you want to calculate the change in the velocity, that is final minus initial. So in vector addition, actually, it's always addition. In the difference here, like even if you're taking a difference, final minus initial, it means final velocity, like final vector, plus the negative of the initial vector in vector addition. So if I want the change in the velocity, so first what I should do, I should draw the final vector. So v. Then I should draw minus u, because it is the change in velocity is v minus u, but in vector addition, it is like v plus and then minus u. So if u is up, what will the direction of the minus u? The minus u will be down. So u is up, minus u will be down. Like we draw v, this was v, and it should be according to the length. You will use your scale or a ruler to measure the length. So first you draw v, then you draw minus u according to the same length. And what about the resultant? The resultant is always from tail of the first to the head of the last. That will be the resultant vector. So whenever we draw the resultant of the vector, it is from the tail of the first, like starting vector, to the end of the last. So this will be the resultant vector. So which one it matched with? So it matches with option B. So in vector subtraction, when we subtract the two vectors, it's also addition. But how we solve? It's like we draw the first vector, then we draw the opposite of the, like we draw the second vector, then we draw the opposite of the first vector. And to get the resultant, it's tail of the first to the head of last. So this is a graph for two objects. We have two objects, one is P, another one is Q, are at the same position at T is equals to 0. The graph shows how the velocity vary with the time. Which of the following statement describe the position of P and Q at time is equals to 4 seconds? Basically, what happened in this case, for when you check for P, first it was having a positive velocity, then it is having a negative velocity. And equal magnitude, like for first it was +1, for 2 seconds it was +1, and then for 2 seconds, like from 2 seconds to 4 seconds or 2 seconds, it is -1. So what it shows, or what does it means? It means that object P first move towards right with a speed of 1 meter per second for 2 seconds, and then it returned back for same time interval. It moved with the same magnitude but in opposite direction with a 1 meter per -1 meter per second, means that it changes its direction, or it reverse the direction and return back to the starting position. And area under the graph, the velocity time graph, area under the graph shows a displacement. So you can see moving towards right, like if this is representing moving towards right and this represent moving towards left, both have the same areas. So if both have the same areas, it means it covered the same distance. First, maybe it moved 2 meters towards right, and then it returned back 2 meters toward left. So means the object P will be there at the origin, or it will be there at the starting point. So P moved towards right, then return back to the same starting point. And how we know it's returned back to the same starting point? Because the area under the graph, the distance moved when it was moving towards right, is same as the distance it moved towards left. Both have the same areas. So moving towards right and moving towards left have the same areas. It means that it returned back to the same starting position. But for this object, you can see it does not change the direction. For object Q, it start, but it does not change the direction, and its acceleration, its velocity is increasing, but its acceleration is decreasing, because the gradient of this graph represents the acceleration. So start with 0, it maximum reaches 1 meter per second. For 4 seconds it moved, but it does not change the direction. As you can see that the positive velocity remains. It is not like first one +1 and then -1. Now we have to check the options, which one matches with the description. So which of the following statement describe the position of P and Q at 4 seconds? Both at the initial position, that's wrong. Because P is there at the initial position, but not Q. P and Q are at the same distance from initial position, that's also wrong. P is actually at the origin and Q has covered some distance from origin. P is further from the initial position. P is not further from initial position, as it returned back to the original position, like initial position or the origin. So P displacement is 0. Q is further from the initial position than P. That's true, because Q does not change the direction. It continues to move. Its acceleration decreases, but it continues to move in a specific direction. So D will be the right answer. In question 5, the table shows some physical quantities which will correctly identify the scalar and the vector. So we have to check which one include the correct position for scalar and which one is for vector. So when we sort out, distance is a scalar quantity, velocity, acceleration is a vector quantity. So A should be the right. What about time? Time is a scalar, speed is also scalar. Velocity is vector, force is vector. Work is scalar, power is also scalar. So the first column we need scalar, and the second column we need vector. So that's why option A is the right answer.